Hello everyone, I'm Hannah Jasmine Santos and welcome back to my YouTube channel. So for today is a rainy day. We will now move to the experiment number 4, which is AND gate. It is the basic operation of a logic multiplication. This gate is composed of 2 or more inputs and a single output. And there must be a 1 at all of the inputs to obtain a 1 of the output. So let's go and perform the experiment number 4, AND gate. The equipment and materials that we need to use in this experiment number 4 is first, the 5 volts DC power supply, the 1-piece 74 LSO8 quad 2 input AND gate, and 1-piece 5mm red LED, 1-piece 1/2 watts 220 ohms resistor, the 2 pieces SPDT switch, our jumper wires or connecting wires. So these two, I bought it in Shopee. I ordered it overseas, so its price is so very cheap. Then the next one is our alligator clip. So let's start the experiment number 4. So in our breadboard, we will first put our IC. After that, you can see that the number 3 of the IC is connected to the positive side of the LED. So we will put our LED here. The positive is this one and the negative is the short one. Then we will connect it by the connecting wires, the jumper wires. 1, 2, 3. And after that, the negative side of the LED is connected to our resistor. Okay, they are now connected. Then the number 7 of our IC is connected to the ground. Here is our 7 of the IC. We will connect it to our ground. Which is the negative side of our breadboard. Then also the number 14 of the IC is connected to the power supply. We will connect it the power supply later here in the positive side of the breadboard. So let's connect. So here's the number 14. Okay. Then after that, the resistor also is connected to the negative side of our breadboard. Look at these connecting wires. So cute and small. It's fit in here. It's actually fit. Okay. Then after that, we will now put our switch. So we will place the switch here in the top. Then after that, as you can see in our circuit, the number 1 of our IC is connected to the switch A, and the number 2 of our IC is connected to the switch B. So let's connect with these jumper wires. The number 1 here is connected to the switch A. And the number 2 is connected to the switch B. Here is our switch A and this is our switch B. So let's connect this. I can't put that, so let's try in this side. Okay, then it's show also that the switch is connected to the positive and to the negative side, which is this 1 and 0. The number 1 is the positive side and 0 is the negative side. So let's connect. Let's try this one. So here is our positive. It's so long. Let's try the other one. Let's try this. Okay, it's fit. And the other one here. And in the negative side also. So let's check our circuit. So the number 1 of our IC is connected to the center of the switch A, and number 2 of our IC is connected to the switch B. Then the number 3 is connected to the positive side of the LED, and the negative side of the LED is connected in our resistor, and the resistor is connected to the negative side of the breadboard. Then the number 7 of our IC is connected to the ground, while the number 14 is connected in the positive side of our breadboard. So let's try to connect it with our power supply. So the information about AND gate, it says that the operation of the AND gate is such that the output is high or 1 only when all of the inputs are high or at logic 1. If any of the inputs are low or at logic 0, the output is low. So when the 2 input is at logic 0, the output of this AND gate is 0. So here, our switch is at logic 0, both switches. Then when we turn the switch B to at logic 1, the output also is at logic 0. And the other one, when we try to make the switch A at logic 1 while the switch B is at logic 0, the output also is at logic 0. But when we make our 2 inputs at logic 1 or high, the output or our LED will turn on and the output is at logic 1. The AND gate is an all or nothing gate because there must be a 1 at all of the inputs to obtain a 1 at the output. So it simply says that the 2 input must be at logic 1 for us to get an output at logic 1. So let's proceed to our next figure. So in our second figure, it shows that the number 3 of the IC is connected to the number 4 and the positive side of the LED is the one who is connected to the number 6 of our IC. And here in the second figure, we will need to add a switch. So here is our switch. So let's put it here. Then that's the only change. The number 5 of the IC is connected to the switch and the switch also is connected to the negative and to the positive. So let's try. So the positive side of the LED will be connected in the number 6. So here is our number 6. Then the number 3 and the number 4 will be now connected. So let's put this little connecting wire here, the small one. The number 3, 1, 2, 3, and the number 4. My God. Okay, let's see if that is number 3 and number 4. So 1, 2, and 3, and 4. So that's right. And now we will put our third switch. So let's place it here. Then the number 5 of our IC is connected to this third switch. Okay, then this side is connected to the positive and this side is connected to the negative. You need to push it. Okay. So let's make sure that the connection is what is on the circuit, what is on the figure, letter B. Then again, the number 1, number 2 is connected to this switch A and B. Then the number 14 of our IC is connected to the positive. Then the number 3 and the number 4, as you can see here, is connected. Then the number 5 of our IC is connected to this third switch. Then our positive side of the LED is connected to the number 6 of the IC, and the rest is at ease. So let's connect this in our power supply. So let's put this in this positive and in the negative. Let's see what will happen. Let's try to turn off the switch first, then let's turn on our power supply. So as you can see here, if the three inputs, which is A, B, and C, is at logic 0, the output will be at logic 0. And next, the letter C, our input C is 0, also input B is 0, then we will turn on this switch A. The output will also be 0. Then the next one, the letter B is the one who is at logic 1, then the output is also 0. So let's try. The switch A and switch B is at logic 1, while the input C is at logic 0. Then the output also is at logic 0. And when we turn off this 2 switch and we turn on the switch C, the output also is at logic 0. But when we try to make this switch A at logic 1 while switch B is at logic 0, the output also is 0. And when we try letter C and letter B is at logic 1 and the switch A is at logic 0, the output will be 0. But when we turn on these 3 switch, which is switch A, switch B, and switch C, when we make this input at logic 1, our output will be at logic 1. So as a conclusion, the first figure and the second figure has a similar, because in AND gate all the input needs to be at logic 1 for us to get a result at logic 1. But when one of these switch is at logic 0, our output will be at logic 0. So that's all for today. I hope you learned something new about this experiment number 4 and about the logic gate and gate. And keep safe, everyone. Don't forget to subscribe and like this video. Thank you.